Hi, in this video we're going to calculate density using our ideal gas law. So ideal gas law is PV equals nRT. Now how do we get density from it? Well, the density formula will be D is equal to pressure times molecular weight. MW is grams divided by moles, molecular weight. And divided by R, which is constant, times temperature. And that is our formula for density. Okay, now our first problem says calculate the density of NH3 at 850 torr and 100 degrees Celsius. So first we use a D is equal to PMW molecular weight divided by RT. Alright, pressure is 850 torr, which we're going to convert into mmHg because 1 torr is equal to 1 mmHg, as they're both 760 at standard pressure. So we're going to convert this to mmHg, and the reason we're converting this to mmHg is because our gas constant only contains kPa, mmHg, and the atmosphere. So let's first convert it to mmHg times molecular weight. What is the molecular weight of NH3? Well, we use our periodic table. We have 14.01 plus H 1.01 times 3. We get 17.04 divided by R, our gas constant. Now, if you remember in the previous video, gas constant for mmHg is 62.4. And finally, we multiply that by our temperature in Kelvin. 100 plus 273 gives us 373 degrees Kelvin. And now what is this equal to? 850 times 17.04 divided by 62.4 divided by 337 gives us 0.622. 0.622. Now for units, we're going to use grams per liter. That is the units for density. Now our second one, we have the density of air at 1 atmosphere and 25 degrees Celsius is 1.186 grams per liter. And that tells us to A, calculate the average molecular mass, which is molecular weight of air, and B, from the previous value, assuming that air contains only molecular nitrogen and molecular oxygen gases, calculate the mass percentages of N2 and O2 in air. So this is a two-step problem, and first let's use our formula. We have D is equal to PMW over RT. Now let's put MW onto one side, and that is what we're looking for. So multiply both sides by RT, we get DRT is equal to PMW. And then we divide both sides by P to get MW, molecular weight, is equal to DRT divided by P. Now let's plug the numbers in. MW is equal to density, which is 1.186 grams per liters, times R, the gas constant when you're using atmospheres, is 0.0821. And finally, the temperature, which is 25 plus 273 gives us 298 Kelvin. All right, divide all of that by pressure. Now pressure is 1 atmosphere. And what does this number give us? 1.186 times 0.0821 times 298 divided by 1 gives us 29.02 grams per mole. The units for molecular weight is grams per mole, and you always run to two decimal places because that is how atomic weight works. Okay, now we found the MW. Now it says calculate the percent of oxygen and nitrogen. So we have 29.1 mole of gas is 29.2. Now let's make that equal to oxygen and nitrogen, right? Oxygen is 16 times 2, which is 32. Nitrogen is 14.01 times 2, which is 28.02. Now let's use 28.01 times x plus 32. And over here, if we use 1 minus x, it's going to give us 2 decimals that should add together to 1. And that tells us the 2 percentages of N and O oxygen. So now let's do this. 29.02 is equal to 28.01x plus 32 minus 32x. And now this subtract over there, 29.02 minus 32 gives us negative 2.98 is equal to 28.01 minus 32 equal to negative 3.99x. Negative 2.98 divided by negative 99. X is equal to 0.7469. So X, which is nitrogen, will be 74.69%. Now 100 minus 76, 74.69 should give us oxygen takes 25.31%. And that is our percentages of N2 and O2 in the air. So this is how you calculate density with the ideal gas formula. And thank you for watching.